You've definitely heard about the new weight loss drugs. They're everywhere. But today, we're going to go way beyond the headlines. We're going to break down the incredible biological machinery that makes them work and why they represent such a huge shift in medicine. All right, let's get into it.
So people who take these medications often describe this really profound change. It's not just that they're less hungry, but that the constant mental chatter about food, what some people call food noise, it just goes quiet. Now, how on earth does a drug do that? How does it change not just your body, but your entire relationship with food? That's the big question we're unpacking today. So here's how we'll do it. We're going to follow the signal right from its natural origin in the body to how these drugs basically put it on steroids. We'll look at how it affects the brain, the stomach, and our metabolism. Then we'll zoom out and see why this is about so much more than just appetite and what it really means for the future.
To really get how these drugs work, you first have to understand the brilliant system they're based on, a kind of secret signal your own body uses every single day.
Okay, so when you eat a meal, these specialized cells in your intestine release a hormone called GLP-1. You can think of it like a messenger that runs around shouting, "Hey everyone, food is here." It's a completely natural, totally essential part of how your body manages energy and hunger.
But here's the catch, and this is where the genius of these drugs comes in. Your natural GLP-1 does its job and then poof, it's gone. It gets broken down by an enzyme in just a couple of minutes. It's a quick sprint. These new drugs, the GLP-1 agonists, are engineered to be marathon runners. They perfectly mimic the natural hormone, but they're built to resist that enzyme. This lets that food is here signal last for hours or even an entire week.
So what does this long-lasting signal actually do? Well, its first, and maybe its most important stop, is the body's command center, your brain. Now, this isn't magic. It's straight-up neurobiology. Your brain actually has these specific landing pads, or receptors, just waiting for this GLP-1 signal. And get this, they're located in the exact regions that regulate your appetite, your cravings, and that feeling of being full. So the drug is literally having a direct, sustained conversation with your brain's hunger controls.
And this is why it feels so different from just dieting. It's not about you fighting your own biology with willpower anymore. The medication actually changes the biological conversation itself. Your brain is getting this powerful, continuous signal that you are satisfied, which just turns down the volume on the drive to go find more food.
Okay, let's move on to the second key mechanism and see how this all builds. So while your brain is getting the message that you're satisfied, your stomach is getting a signal to help create the physical feeling of fullness.
The technical term for it is delayed gastric emptying. I know that sounds complicated, but all it means is that GLP-1 tells your stomach to, take its time, to slow down the whole process of digestion and just hold on to food a little bit longer before sending it along.
And the effect of this is super direct. You end up eating less to feel full in the first place, and that feeling of fullness lasts much, much longer. It's an incredibly powerful 1-2 punch. Your brain feels satisfied, and at the same time your stomach feels physically full.
But believe it or not, the story doesn't end with just hunger and fullness. GLP-1 is also a master regulator of your metabolism, and its third stop, the pancreas, is where it performs one of its most elegant tricks.
So let's just quickly put it all together. You eat. That GLP-1 signal is released and then amplified by the medication. That signal then travels to the brain to reduce hunger, to the stomach to increase fullness, and, crucially, to the pancreas to optimize your blood sugar.
Now this is what makes the system so incredibly smart. GLP-1 tells the pancreas to release insulin, but, and this is the key part, only when it detects that blood sugar is rising after a meal. At the exact same time, it tells the pancreas to stop releasing another hormone called glucagon, which basically prevents the liver from dumping extra sugar into your blood. It's this intelligent dual-action system that fine-tunes your blood sugar in real time.
So what's the result when you put all these coordinated actions together in the brain, the stomach, and the pancreas? Well, the clinical impact is just profound. We're seeing total body weight loss anywhere from 7 to over 24% in major trials. I mean, that's a level that actually starts to rival the effects of bariatric surgery.
And this brings us to a really crucial misconception. If you're thinking of these as just powerful appetite suppressants, you're honestly missing the bigger and, frankly, more exciting picture. Is it really just about eating less? The answer from a growing mountain of research is a very clear and definitive no. The benefits seem to extend far beyond the calories you happen to consume.
What we're seeing is that these drugs have what we call pleiotropic effects. That just means they have multiple actions across different body systems. For instance, clinical trials are showing a significant reduction in major cardiovascular events, things like heart attacks and strokes. There's also evidence for widespread anti-inflammatory effects, better functioning of our little cellular powerhouses, the mitochondria, and even potential protective effects in the brain.
And because of all this, the scientific community is really starting to reframe them. They're not just weight loss drugs. A better term is comprehensive metabolic modulators. They're retuning these fundamental systems across the entire body.
So what's the big takeaway from all of this? Why is this such a transformative moment in medicine?
Ultimately, these drugs don't really introduce some foreign process into your body. They work by essentially hijacking and amplifying a natural, elegant system that our bodies already use. They're just turning up the volume on a healthy signal that, for some people, may have become a little too quiet.
And this is exactly what the research means when it calls this a paradigm shift. We're moving away from just treating a single symptom and moving toward a multi-system intervention that addresses the deeply interconnected biology of metabolic disease. And this leaves us with a really fascinating question for the future, right? We've only just scratched the surface of understanding this incredible communication network between our gut and our brain. As we get better at listening to and modifying these signals, what other conditions, from neurodegenerative diseases to autoimmune disorders, might we be able to treat by simply hacking our own internal messengers? The possibilities are really just beginning to unfold.